Hi, today we're going to learn more about we're going to do more on logarithm and exponentials. So before we do some problems, I'm going to just go to review some of these some of these rules because we need these rules to do some of the problems. So we're going to the first one is the definition of logarithmic function. So it's basically saying y equals log base a times x if and only if a to the y equals x. So we're going to use that a lot. And then the second one is the power rule for logarithm. So it's basically log base a times m to the n equals. So basically the log rule is whenever you have a power, you just put it in front of the log. So it's going to be n times log base m, n times log base a times by m. So yeah, that is the power rule. Power rule of logarithm for logs. I'm only going to do a few because this is just yeah, so I'm going to do the first problem says we got to solve each equation. So it says each of these equations are in a single logarithm, and then we got to solve each equation. So our goal is to solve for x. So I'm going to use the number one rule. So I'm going to use y equals log base a times x if and only if a to the y equals x. A to the y equals x. So let's look at this equation. Negative 2 equals log base x times by 4. So what does this look like? Does it look like this part, like this equation, or this equation? It looks like this, right? So if it looks like this, let's figure out our a, our x, and our y. So what do you think our y is? It's always on the y is always on the right or the left side, right? So our y is going to be negative 2. What is our a going to be? Our base? Our base is going to be just x. And what is our x going to be? Our x is always inside the parentheses, so our x is just positive 4. Good. So if we know our a, y, and x, let's put it in this form, a to the y equals x. So a is x. Our y is negative 2. Raise it to the negative 2 because a to the y equals x, which is 4. Okay, so our goal is to solve for x, right? But before I simplify, I'm going to make this, we have a negative 2, so let's make that positive. So to make it positive, it's going to be 1 over x squared, or x positive 2, equals 4. So now what I can do is cross multiply. So if I cross multiply, I get 1 equals 4x squared. I'm going to divide both sides by 4. So I get 1/4 equals x squared. Good. So now when I gotta solve for x, so I'm gonna take the square root of both sides. So what happens when you take the square root? You get two answers. So you're gonna get plus or minus, and the square root of 1/4 is 1 over 2 equals x. So you have two choices. You have two answers: plus or minus 1/2. But we gotta make sure we gotta check both of them to see if it works. Can we use the negative 1/2? I don't think we can use negative 1/2, right? We can't use negative 1/2 because when you put it back to the original equation, your base can never be negative. So negative 1/2 is not an option. Let's try positive 1/2. Let's put positive 1/2 into the original equation. So it's going to be negative 2 equals log base 1/2 of 4. So what is our y is still negative 2. Our base is no longer going to be x, it's going to be 1/2. And our x is still 4. So put it in ay equals x form. So a is 1/2 to the y, which is negative 2 equals 4. It's just like the other problem, you have to make this positive, so I'm going to do 1 over 1/2. One-half square equals 4. If I were to simplify this, this is going to be 1 over 1/2 square is 1 over 4. And then on the left side, I'm going to we have to simplify this, so I'm going to multiply both sides by 4. So 1 times 4 is 4, and then 4 times 1/4 is just 1. So you get 4 over 1 equals 4. That is true, right? 4 over 1, or is the same thing as 4. So we know that x is positive just 1/2. We won't have a negative 1/2, just positive 1/2. Okay, what about this problem? X times natural log 3 equals 2 minus x times it by natural log of 2. Okay, so what is the question asked? It says each of these equations involves more than one logarithm. Solve each equation, give exact solution. So our goal is to solve for x, and then we gotta we just gotta solve for x. So this one is so we have x times natural log 3 times 2 minus x times ln of 2. Can we simplify this even more? We can. We can simplify the right side, right? We can simplify this. We're going to distribute this. So this 2 is going to be 2 times ln of 2, and then this negative x is going to multiply by ln of 2. So we're going to simplify the right. So the right side is going to be 2 times ln of 2. So what I'm doing is just foiling, and then minus x of ln of 2. The left side stays the same. Okay, so remember our goal is to solve for x. Where do we have an x? We have an x right here, is this negative ln of 2, and then this ln x times ln of 3. Let's move all the x's on one side, and then so let's move this to the right. So I'm going to move, how I do this, how I move it to the right, I'm going to add x of ln of 2. Add x ln of 2. So on the left side, you're going to have x ln of 3 plus x ln of 2 equals, remember this, we didn't do anything to this one, so this just stays where it is. So it's going to be 2 ln of 2. So this cancels. So we have all the x's on the left side, so we can factor out an x, right? So I'm going to say x, and then I'm going to use bracket, and I'm going to multiply this by ln of 3, because ln of 3 times x is x ln of 3, and then I'm going to plus 1 of ln of 2, right? Because when I multiply x times 1 ln of 2, I get x ln of 2 equals 2 ln of 2. So this stays the same. Now, our goal is to solve for x, so I'm going to divide both sides by this whole thing. Ln of 3 plus, we could just say ln of 2, because ln of 2 is the same thing as 1 times ln of 2. So I gotta do it on the right side as well. Okay, so I can simplify this even more. So the top stays the same. 2 ln of 2, that still stays the same. Now the denominator, ln 3 plus ln 2, we can simplify that as ln of 6, because remember the rule for logarithm, when you're adding with the same base, so our case is, our base is natural log, when you're adding with the same base, you're really multiplying. So it's going to be 3 times 2, which is 6. You can put this in the calculator, but 2 ln of 2, but I would use parentheses. So if you put this in calculator, put this in parentheses, and then put this, and when you put this in calculator, just put it the way it is. So when I put that in the calculator, I get x is about approximately 0.7737. Okay, so the problem, it didn't say to round how many places, but for me, I'm just going to round it to 2 decimal places because it's going to make it much easier. So I'm just going to round it to 2 decimal places. The book says to give exact solution, but I'm going to round it to 2 decimal places because when I check it, I got to put it back to the original equation. So when I put 0.7 back to this equation, right? So this is going to be, if I put x, so wherever you see an x, you're going to put a 0.7. So 0.77 times it by natural log of 3 equals 2 minus 0.77 times by natural log of 2. And when I get that, the left side, I get 0.845, and then on the right side I get 0. These are just the exact solution I got. So I got 0.8525, and if I see these numbers are really close, I'm just going to round it to 2 decimal places. So this is going to be 0.85, and this is still going to be 0.85. So they're pretty much the same, so it's true. So we know that x is about 0.77. Let's try this one. How about 9 equals e to the negative 3x squared? So number 29 says, each of these equations involves a single exponential expression. Solve each equation, round approximate solution to 4 decimal places. So we got to solve for x, and then we got to round to 4 decimal places. So let's see here. This is an exponential equation. Can we get the same base? So we have a base of 9 in e. Can we get it in the same base? No, we can't. So when you can't have the same base, you got to take the natural log or the log. In this case, I'm going to use natural log because natural log raised to the e power cancels perfectly. So you're left with the exponents, right? So that's why I'm going to use natural log of both sides. So I'm going to do, on the left side, it's going to be natural log of 9 equals natural log of e to the negative 3x squared. So remember, when you have a natural log and an exponential, they cancel each other because they're inverses. So you're left with the exponents. So you're left with negative 3x squared and then natural log of 9 So our goal is to solve for x, so I'm going to divide everything by negative 3, negative 3. So over here you're left with x squared. So okay, so when you put natural log of 9 divided by negative 3, putting it in the calculator right now, you get negative 0.73. Now this is going to conflict because negative 7.32, when you take the square root, you can't have a negative number in the square root. So then you'll deal with imaginary numbers, and we can't do imaginary numbers for exponents. So this case, our answer is no solution, because you cannot have a negative number inside the square root. So it's just not possible. Let's try this one. So we have 3 negative x equals 30, right? Okay, so it's the same rule from the last one. We gotta solve for x and then round to 4 decimal places. Okay, so this is an exponent. This is an exponential problem, not a logarithm. Okay, so first step is check if you can put the same base together. So we have a base of 3 and 30. Can we have a common base? I don't think we can. So what we're going to do is we're going to have to take logs of both sides. Notice that I'm not going to use natural log because I don't have an e anywhere. So I'm going to use log. So I'm going to do log of 3 to the negative x equals log of 30. Okay, so remember, we're going to use, for this one, on the left side we have log 3 to the negative x. So remember our power rule for logarithms, whenever you have an exponent, you put it in front of a log. So number 2, right? Whenever you have an exponent, you put it in front of the log. So over here, this negative x is going to be in front of the log, so it's going to be negative x log 3 equals log of 30. So remember, our goal is to solve for x, so I'm going to divide both sides by negative log 3, because there's a negative right here. Negative log 3. So our x is about, negative 3.09559,032, right? That is what I get approximately, and then we have to round it to 4 decimal places. So this is 1, 2, 3, 4. Wait, 2, 3. No. It's, yeah, this part. So 1, 2, 3, 4. So our 0 is not greater than 5, so it's going to be negative 3.0959234. Yes. Now the next step is to put it back into the original equation to make sure it's true. So this is going to be 3 to the negative 3.0959 equals 30, right? So if you put this in the calculator, you should get, first step is, no, what I'm going to do is, yeah, put this in the calculator, or you can simplify it as 1 over 3 to the positive 3.0959. So put it in the calculator. I'm putting it in the calculator right now. So it's going to be 1 divided by, or 3 to the negative 3.0959. I did not, actually I put it in, where did I put it in? You should get, they should be true if you were to put it in the calculator. You could also, you could have put it in this equation as well. I think that's where I put it in. I put it in this equation, and it turned out to be true. So let me just put it in that equation. Log base 3 raise it to the negative 3.0959 equals log of 30. So yeah, if you put this in the calculator, they should be true as well. So I know this is the correct solution. Let's do this one. So we are given 2 raised to the x minus 1 equals 4 to the 3x, right? So this problem asks us is each of these equations involves more than one exponential expression. Solve each equation, round approximate solution to 4 decimal places. So remember, like the last problem, we got to solve for x and then round our answers to 4 decimal places and check the answer. So what kind of equation is this? This is not a log, but an exponential. So if it's an exponential, let's try to figure out, can we get the same base? So we have a 2 raised to the x minus 1 equals 4 to the 3x. We can have this common base, right? We can have a common base of 2, but this one stays the same because it has a base of 2. But on the right, we can change it as, what's another way to writing 4 in the common base of 2? We get 2 square, right? 2 square. And then you have to raise this to 3x. Remember, don't forget about this 3x. So raise it to 3x. What is the rule of these when you have to raise it to you're raising a power to another power. So what you're really doing is multiplying the exponents, not adding, right? So this is not the same thing as x cubed times x squared, right? This would be x to the 5th. It's like saying x cubed, raise it to the 2nd power. That is going to be x to the 6th. So this one is like this one. So this is going to be 2 to the 3x times 2 is 6x. 2, and then the left is still the same, 2x minus 1. So when you have the same base, you could just pretend it doesn't exist and bring down the powers. So on the left, it's just going to be x minus 1 equals 6 to the x. And then we got to solve for x. So what I'm going to do is I can subtract 6x, negative 5x, minus 1 equals 0, and then I could add 1. There's more than different ways you can do this. So this is negative 5x equals positive 1. Divide everything by negative 5, negative 5. So I get x is negative 1/5. Or could say x to equals in decimal places, in points, decimal would be negative 0.2. Okay, so I gotta check if this is true. So I'm gonna put it in this equation, the original, or you could put it in this one. It doesn't matter. I'm just gonna put it in the original. So it's gonna be 2 to the negative 0.2 minus 1 equals 4 to the 3 times negative 0.2. So if you were to simplify this is going to be 2 to the negative 1.2, and then this is going to be 4 to the negative 0.6. And when you do the calculation, when you put it in the calculator, the left side is 0.43527. This is going to be 0.43527. So they're true because they're pretty much the same thing. So x is negative 0.2. And this is I can't round it to 4 decimal places because this is the exact solution. Two more and then we're done. Yeah, just 2 more. So let's do this one. We have a 2 to the x times 2 to the x plus 1 equals 4 x squared plus x. So this one says solve. It's the same as the last problem. We got to solve the problem, solve for x, and then round the answers to 4 decimal places. So what kind of problem is this? This is not a log, it's an exponential. We can simplify this. Let's simplify the left. So this is 2x times 2 to the x plus 1. So this is a power rule. So remember the power rule if you're when they are multiplying with the common same base, so x cubed times x 4 is going to be x to the 5, 6. So when you're multiplying exponents with the same base, you're really adding. So this is going to be x to the 7. 4, 5, 6, 7. Yeah, this is going to be x to the 7. So we got to do the same base, same rule as this. So this is going to be 2 to the. We got to add these powers. So it's what is x plus 1? So that's 2x plus 1, right? 2x plus 1. And then on the right, let's get a common base of 2. So what's in a way of writing forward in the base of 2? It's going to be 2 squared. And then don't forget about this x squared plus x. So you've got to distribute, because we're raising it power to another power, so this is going to be 2. When you're distributing, when you're raising a power to another power, you have to actually multiply the exponents. So this is going to be 2x squared plus 2x. Yes, 2x. And this is, the left side is going to be 2 to the 2x plus 1. Now we have the same base, right? Base is 2. Just drop it, pretend it doesn't exist, and then bring down the exponents. So you're left with 2x plus 1 equals 2x squared plus 2x. So now we got to solve for x. So what I'm going to do is I'm going to subtract 2x from both sides. So this 2x cancels. We're left with 1 equals 2x squared, divide everything by 2, so you're left with 1/2 equals x squared. I gotta solve for x, so I'm going to take the square root of both sides. And when you take the square root of both sides, you're going to get a positive and a negative. So you're going to get x equals plus or minus 1 over square root of 2. Now I'm going to you can rationalize the denominator by multiplying top and bottom by square root of 2. So you're going to get square root of 2 over square root of 2 times square root of 2 is positive 2 because the square root cancels. And yet, remember, it's still plus or minus. You're going to get a plus or minus square root of 2. So let's start trying the positive square root 2 over 2. So yeah, let's put it in this equation because this is the most simplified. No, let's put it in this equation because this is probably the most simple. We could put it in this one, but it's gonna be a little bit more complicated. So let's put it in this equation because everything is more simplified. But yes, you can put it in this equation as well. So so that's 2 times 2 square root of 2 over 2 plus 1 equals 2 square root of 2 over 2 square plus 2 square root of 2 over 2. When you put it all in the calculator, you should get, on this side, you should get 2 raised to the 2.4142, and then this is going to be 2 to the 2.4142. And I don't have to simplify it because they're pretty much the same thing, right? 2 raised to the same power. So these are true. So I know positive is true. Now let's try the negative. Negative. And then if you put the negative square root of 2, negative square root of 2, negative square root of 2, on the left side you're going to get 2 to the negative 0.414, and you get 2 to the negative 0.414, right? So this is true as well. I don't have to put it in the calculator because I know this is the right and the left looks the same, so that's true. So both of these answers are true, plus or minus. So our answers is plus or minus square root 2 over 2. And then our final problem, the last one, we are given 1 over 2 raise it to the 2x minus 1 equals 1/4 raise it to the 3x plus 2. Okay, so this problem says solve each equation, round approximate solution to 4 decimal places. So we got to solve for it and solve for x, right? And then round it 4 decimal places. So what kind of equation is this? This is an exponential equation, right? So first step is I'm going to check if we can have the same base. Let's try to put the base, everything in the base of 1/2. So the left stays the same. what's another way of saying 1/4 in the base of 1/2, right? So it would be 1/2 square, and then you have to raise this to the 3x plus 2 power. So when you're raising power to the power, you multiply the exponents. That's just the rule. So it's going to be 1/2 times 2 times 3x is 6x. And then 2 times 2 is just positive 4. And then the left just stays the same. 2x minus 1. Since they have the same base, you can just pretend it doesn't exist for right now. So you're left with, on the left is 2x minus 1 equals 6x plus 4. And then we got to solve for x, right? So what I'm going to do is add 1 to both sides. So you get 2x equals 6x plus 5. And then I'm going to subtract 6x. So I'm left with negative 4x equals, and then the 5 stays the same. And then I'm going to divide both sides by negative 4, negative 4. So I get x equals negative 5/4, right? So we got to check if it's true. So I will put it in the, which one? I'll just put it in the original one, right? So it's going to be I'll just put in the original one. So when you put it all in, when you simplify, the left should be 1/2 raise it to the negative 14/4 equals, and then the right side should equal 1/4 raise it to the negative 7/4. So on the left, you should get, if you put this in the calculator, you should get 4096. And on the right, you should get exactly 4096. So that's true. So we know that x must equal negative 5/4. So yeah, you always have to check the solution if it works. And this wraps it up for this section.